Hello and welcome to Module CCS 15 on measures to mitigate contamination risks. This session will discuss measures you can take to mitigate contamination risks in clean rooms. In today's session, we will cover the measures implemented to minimize contamination risks such as temperature and humidity, environmental control, maintenance, controls, monitors and alarms, and clean room design optimization. Here are 3 key points for minimizing contamination risks related to temperature in clean rooms. Firstly, you must have consistent temperature control, i.e. keep the clean room at a steady temperature to prevent conditions like condensation that can lead to contamination. 2. Temperature monitoring systems. Use temperature mapping and continuous monitoring to detect any variations. Ensure sensors are calibrated regularly to maintain the required temperature. And 3. Commission HVAC systems. Make sure HVAC systems are properly commissioned and properly maintained to keep the clean room within the correct temperature range, reducing contamination risks. Maintaining appropriate relative humidity levels is crucial for preserving the chemical stability and physical properties of pharmaceutical products. Fluctuations in relative humidity can affect product formulations, leading to degradation, agglomeration, and changes in texture and appearance. Cold processed pharmaceutical products, such as vaccines and certain biologics, require low room dew point to prevent condensation. Hygroscopic pharmaceutical products absorb moisture from the air, requiring humidity levels lower than those standard HVAC systems can typically provide. In such cases, desiccants or specialized humidity control systems are necessary. Airlocks play a crucial role in low humidity clean rooms by minimizing moisture ingress from external environments. These controlled entry and exit points help maintain stable relative humidity conditions within sensitive areas of the facility. Maintaining appropriate humidity levels is essential for assuring personnel comfort within pharmaceutical facilities. Controlling humidity helps mitigate issues such as dryness and discomfort, thereby promoting a conducive work environment for staff. Humidification also addresses the critical need to manage dust explosion risks in pharmaceutical manufacturing processes. By maintaining optimal humidity levels, facilities can minimize the potential for static electricity buildup and reduce the likelihood of dust particles becoming airborne and combustible. In pharmaceutical settings, clean steam is the preferred method for humidification due to its purity. Humidification systems must be free of contaminants that could potentially contact pharmaceutical products or processes. Effective humidification control systems require precise sensor placement and safety monitors to prevent over-humidification. Pharmaceutical manufacturers implement rigorous procedures for monitoring and validating processes to detect deviations, ensure consistency, and maintain product integrity. Continuous monitoring supports regulatory compliance throughout production. Engineers identify and assess critical variables affecting product quality and process performance, including environmental conditions, raw materials, and equipment functionality. Controlling these variables is crucial for system performance and regulatory compliance. Robust control measures reduce variability in key parameters such as temperature, humidity, air quality, and process timing. Cleanroom facilities use routine environmental monitoring to ensure cleanliness, including regular air quality, surface cleanliness, and particle count testing. In cleanrooms, stable HVAC performance is crucial for regulating temperature, humidity, and airflows, which affect product stability and operational consistency. Facilities set criteria for parameters like particulates, microbial counts, temperature, humidity, and pressure based on room grade and criticality. Alarm points are established at the limits of these criteria to trigger immediate corrective actions, preventing product contamination and maintaining environmental integrity. To prevent contamination between areas of varying cleanliness, airlocks use a multi-step pressurization cascade. This ensures air flows from cleaner to less clean spaces, reducing the risk of contaminants moving into controlled environments. For ISO class 6, 7 or 8, 3 pressure steps are typical. For ISO class 5 or cleaner, 4 pressure steps are preferred. Specialized environments may require additional measures such as enhanced air filtration, negative pressure systems or robust containment barriers to manage fumes or biological agents. Airlocks required time delays are crucial for contamination control and regulatory compliance. Cascade airlocks feature a series of rooms with increasing cleanliness levels, ensuring air flows from cleaner to dirtier areas, used where stringent cleanliness is required. Bubble airlocks, a single room with controlled air pressure prevent contamination, common in labs or facilities handling hazardous materials. Sink airlocks remove contaminants from personnel before entering cleaner areas, with equipment to clean or disinfect clothes and shoes, used in healthcare and hygiene sensitive environments. Dual compartment airlocks, 2 chambers with doors that don't open simultaneously, maintaining pressure differentials and minimizing particle transfer. Double door airlocks, 2 sets of doors with an intermediate chamber to ensure only one door opens at a time, enhancing cleanliness controls, especially in semiconductor manufacturing. An incorporated time delay ensures effective air exchange by allowing HEPA filtered air to replace air volumes before a second door opens. Thank you for watching this introduction to this module. If you'd like to watch the remainder and get 25% off our Contamination Control Fundamental Program, head over to our website at pharmalliance.ie/training-programs and use code YT25OFF. Please do it now as spaces are limited and it's expiring soon. Thank you for your time. We'll see you on the next module.